Hello everyone, dear students. Today in this lecture we will be discussing about the classification of aggregates. Okay, before I proceed to the classification of aggregates, let's start with the introduction. Okay, just we will know about the concrete. You might have all heard about this concrete. What is this concrete? Concrete is a composite material wherein a binding material, that is cement, when mixed with water binds the inert particles of fine and coarse aggregates. This is the definition of concrete. Okay, so there are three major constituents of concrete, that is binding material, which is known as cement. Okay, and then second one is water, and the third constituent is aggregates. Aggregates may be fine aggregate or coarse aggregate. Cement when mixed with water makes a paste, so aggregates are the solid particles other than the paste. The aggregates are further divided into fine aggregates and coarse aggregates. That's why four constituents of concrete are there. Cement, the second one is stone aggregates, which is known as coarse aggregate, and sand, which is known as fine aggregate, and water. These constituents makes concrete. Okay, next we will move on to study the aggregates. It is very important for us because aggregates makes up between 70 to 80% of the volume of normal concrete. These aggregates are mixed with binding material, which may be cement or lime. Nowadays cement is used as binding material, but lime was a common binding material in past. Okay, but nowadays usually cement is going to be used. Natural sand, gravels from riverbed and crushed rocks are used as aggregates. Aggregates to be used in construction must have these qualities, that is, aggregates must be strong and it should be durable, and then it has inert properties, and it should be of appropriate size. The aggregates must be strong. The strength of the aggregate should be more, so that they should not crush under the influence of load, and the aggregates should be durable. Durability is related with service life. Service life of aggregates should be more. Next, in another quality of aggregate is inert nature. That means the aggregate should be inert. It means it should not reactive. It should be non-reactive. They should not react with cement or water. The next one is appropriate size, and the aggregates must have an appropriate size. Okay, the next we'll move on to the classification of aggregates. Aggregates are classified in many ways. The first one is aggregate classification based on its geological origin, and then aggregate can be classified based on shape. Aggregate can be classified based on unit weight. Aggregate can be classified based on its size. We will just go through one by one. Let's move on to the first one, that is aggregate classification based on geological origin. There are two different types of aggregates, that is natural aggregates and artificial aggregates. Based on its geological origin, there are two aggregates, that is natural aggregates and artificial aggregates. Natural aggregates are obtained by crushing of rocks from crushing of igneous rocks or crushing of sedimentary rocks or crushing of metamorphic rocks. Most widely used aggregates are from igneous rocks. Gravels and sand reduced to their present size. When gravels and sands are reduced to their present size either by crushing the rocks or by natural agencies. Okay, that is about the natural aggregates. The next one is artificial aggregates. Artificial aggregates are man-made materials which are made by human beings in the industries. The examples of artificial aggregates are broken bricks, which are also called brickbats. When burnt bricks are broken to the size of aggregates, then it can be used as aggregates in concrete. The next example is blast furnace slag. Blast furnace slag can also be used as an aggregate. Blast furnace slag is formed in blast furnace during the manufacturing of iron. So, blast furnace slag aggregates have good fire resistance but are responsible for corrosion of reinforcement. It means the steel which is used in concrete. Blast furnace slag cement may corrode the steel which is present in concrete due to the sulfur content. The sulfur which is present in blast furnace that may react with the steel present in the reinforcement and it may start corrodes. Okay, that is the one of the disadvantage. The next is synthetic aggregates. Synthetic aggregates are found in thermal process in industries. Usually lightweight aggregates are formed with the help of these synthetic aggregates. Okay, this is the classification of aggregates based on its geological origin, that is natural aggregates and artificial aggregates. Let's move on to the next classification, that is aggregate classification based on shape. Based on shape, there are 4 different types of aggregates. Okay, that is number 1 is rounded aggregates. The next one is irregular aggregates. Next is angular aggregates. Coming to the first one, rounded aggregates. These rounded aggregates are obtained from the river or seashore. And these aggregates, when they are used in concrete, have less voids, and these concrete they have less voids and then less cement paste is required. To bind these aggregates, less cement paste is required. But the rounded surface of these aggregates leads to, that is, because of this round surface of the aggregates, it is unsuitable for high strength concrete and pavements. Coming to the second type of aggregates, that is irregular aggregates. Irregular shape aggregates, you can see in the sketch. When these aggregates are placed in concrete, they have more voids than the rounded aggregates. So more cement paste is required, and such aggregates are suitable for making ordinary concrete. Irregular shape of aggregates are suitable for making ordinary concrete. Okay. Next, third type of aggregate is angular aggregates. These aggregates having sharp, angular and rough particles, and when placed in concrete they will form maximum voids. and these angular aggregates are the most suitable aggregates for high strength concrete and road pavements, concrete pavements. Okay, that is about this angular aggregate. Let's we'll move on to the fourth type of aggregate based on its shape, that is flaky and elongated aggregates. There is some difference between flaky and elongated aggregates. Flaky aggregates are defined as whose least lateral dimension is less than 0.6 times the mean dimension. You can see here in the sketches the flaky aggregates are lengthwise more. Okay, totally flaky aggregates is defined as whose least lateral dimension is less than 0.6 times the mean dimension. Okay, in aggregate is having the mean dimension. You can see the sketch here. Flaky aggregates, they are like just like plate like particles. Okay, one dimension is smaller than the mean dimension, so it is just like a plate. You can see here in the sketch. Okay, next we'll move on to the next type, that is elongated particles. The length of the elongated aggregates is 1.8 times more than its 1.8 times the mean dimension. Okay, they are elongated, they are lengthier when compared to flaky, and here the length is much more than the other dimensions. Both of these flaky and elongated aggregates adversely affect the durability of concrete. That means the presence of flaky and elongated aggregate in concrete affects the durability. So the use of flaky and elongated aggregate is restricted to a maximum of 15%. Not more than 15% of flaky and elongated aggregates are going to be utilized in any concrete making aggregate. Okay, these aggregates are not going to be used in much quantity. Hope you understood the classification based on the shape, that is angular, flaky and elongated, rounded and irregular. Coming to the next classification, that is aggregate classification based on its unit weight. Based on its unit weight, there are three different types of aggregates: normal weight aggregates, heavy weight aggregates and lightweight aggregates. Normal weight aggregates are having the specific gravity of 2.5 to 2.7. Heavyweight aggregates specific gravity is more than the normal weight aggregates, and the range is between 2.8 to 2.9, and there is no particular specific gravity for lightweight aggregates. The unit weight in kilonewton per meter cube is shown for normal weight aggregates and heavy weight aggregates and lightweight aggregates. You can see the unit weight. The unit weight of normal weight is 23 to 26, heavy weight is 25 to 29 kilonewton per meter cube, and for lightweight aggregate is 12 kilonewton per meter cube, and the bulk density is also shown in kg per meter cube. Okay, and the examples for normal weight aggregate is sand, gravel, granite, sandstone and limestone. Examples of heavyweight aggregate are magnetite, barite and scrap iron, and the examples for lightweight aggregates are dolomite, pumice, and cinder. Okay, hope you understood the classification based on the unit weight. Next, we'll move on to the classification based on aggregate classification based on size. There is one of the important classification based on its size. Based on its size, there are two different types of aggregates, that is fine aggregate and coarse aggregate. The size of aggregate. Coming to the first one, that is fine aggregate, and this classification is the most commonly known classification in construction industry and the most important classification. Okay, fine aggregates. Move on to the fine aggregates. Fine aggregates are those aggregates which are having particle size less than 4.75 mm. It means the particle size of fine aggregates is 4.75 mm, less than 4.75 mm. It means the particles will be passes through the sieve of 4.75 mm to 0.075 mm. Another category is coarse aggregates. Particle size in the coarse aggregate is bigger than 4.75 mm and smaller than 75 mm. Okay, hope you understood the classification. The fine aggregate and coarse aggregate, only the difference is the size of the aggregates. If the size of the aggregates is less than 4.75 mm, it is said to be fine aggregate. If the size of aggregate is greater than 4.75 mm, it is said to be as coarse aggregate. You can see here in the sketches the fine aggregate and coarse aggregate. Okay. And coming to this fine aggregate, details of fine aggregate. Particle size is 4.75 mm to 0.075 mm. The fine aggregate can be used. Examples for fine aggregates are natural sand, which is obtained from river or seas. You can see in the sketch. And then crushed stone aggregates, when stones or rocks are crushed into the particle size of sand. Crushed gravel aggregates, when the stones or gravels are crushed into the size of fine aggregate. Surki is the powder obtained from burnt bricks, can also be used as fine aggregate. And cinder, it is the slag which is obtained from metal furnace. So these are all the fine aggregates. Okay. Next is natural sand, usually used as fine aggregate in mortar and concrete. What is natural sand? Natural sand is granular form of silica. These are all the grains of silica. When this sand may be obtained from pits or from rivers or from sea. Based on sources of sand, it may be pit sand, river sand, and it may be sea sand. Okay, pit sand. If the sand is obtained from the pits of found in disperse, is you can see here. Okay, these are all the sources of sand. This sand is obtained from this pit sand is obtained by forming pits to certain depth, by digging the pits to obtain the sand. Okay, the sand obtained from these pits is having sharp angular grains. This is usually free from salts, and for making concrete or mortar, clean pit sand free from organic matter and clay should only be used. If it is clean, it can be utilized for making the mortar or concrete. The next is river sand. This river sand is obtained from beds of rivers. Usually the river sand has fine rounded grains and the color of this sand is white, and this river sand is usually available in clean condition. Okay, next coming to the sea sand, which is obtained from the seashores, and it has the rounded grains. The size of the grains are rounded due to the impact of water, and the color of sand is light brown, but it contains salts. Yes, because of these salts, this sea sand is not recommended for any engineering works, but it can be used after being thoroughly washed. Okay, that is about the fine aggregate. Next we'll move on to the coarse aggregates. Okay, coarse aggregates particle size ranges from 4.75 mm to 75 mm. The size of coarse aggregate here is greater than 4.75 mm but lesser than 75 mm. The examples may be broken stones, you can see in the sketch, gravels, broken bricks, and clinker. Okay, these are all can be used as coarse aggregates. Okay, I hope you have understood the classification of aggregates based on its size, that is fine aggregates and coarse aggregates. Thank you so much for watching this video. Thank you. Sorry, before I end up this session, I'll just give you some questions. Please try to reply. Please try to answer these questions. Okay, these are some of the questions. Just go through these. After these questions, I'll be putting a small video on the classification of aggregates based on its size. Please watch this, and then we'll end up this session. Thank you so much.